Good evening, everyone. Thank you so much for joining on time. Today, I take the privilege of introducing Mr. P. Suryakumar, who's a master teacher educator in mathematics and physics and a curriculum developer specializing in hands-on activities. He's the founder and managing director of Ganit Genie Private Limited, which began with a passion and a mission of making mathematical sciences meaningful. He has taken a number of education initiatives across the country and has conducted few hundred workshops and training programs for school, college teacher, and students in mathematics and science. His hands-on activities and the integrated math and science approach are very popular and has made a difference in the lives of several hundred students. Thank you so much, sir, for taking out the time today. And it is our privilege, and I hope we all benefit from him as millions have benefited already. Sir, the stage is yours. Thank you so much.
Thank you very much, ma'am. So good evening, all of you. So today, this session is actually based on crafting MCQs, and I have been doing this for the last 22 years. So I started my career in training students for JEE and Olympiad. So from 2000 onwards. So right from day one, my job and my work is always creating or designing multiple choice questions. But when it comes to crafting MCQs, I just named it as crafting MCQs for one particular reason. It's not writing questions actually, right? So even it's an art when it comes to multiple choice questions, it's particularly an art designing that question itself. So if you look at multiple choice questions, our objective needs to be really very clear. So there are different objectives. So let's focus on these objectives here. So see, one objective is particularly when it comes to mathematics, we can actually identify mathematically inclined students. Okay, so that is a different set altogether. So your objective should be like, are you preparing questions to identify mathematically inclined students? Is that one question? The second is, are you preparing questions to eliminate and select students? You know what I'm talking about. Elimination and selection comes from all the competitive exams. They don't select and eliminate, they eliminate and then select. Okay, so that is the process they follow. And the third one is for, in normal schools, what we do is we assess learning outcomes and then help students learn better. So out of these three, what is our objective? Right? So are you going to design questions for assessing learning outcomes and then helping students, or are you going to design questions for identifying mathematically inclined students? Because each one has a different parameter. Now, say for example, if I'm going to take the first objective, identifying mathematically inclined students, I would focus more on the depth of mathematics and the why of mathematics. Okay, so that is what I would focus on if my objective is going to be identifying mathematically inclined students. Or say if I'm going to design a question for some kind of a selection process, so where I'm going to eliminate a lot of students. If you look at JEE or any kind of entrance exam for that matter, so last year we had around 15 lakh students, where approximately we have around 50,000 seats, and they eliminate 14.5 lakh students altogether. So if that is going to be my objective, then the design of the question is going to be a little bit tricky. I won't be bothered about the why of math, but it's going to be a lot of tricky questions. So that would be my objective. Or the third one is like, if I'm going to help students learn better, so then here I would focus more on the formative assessments. So I will design questions in such a way that I want to help my students learn better, understand the concepts better. So my question design would be simply different from the other two objectives. So this will be for formative assessments. So I have these three objectives clear in my mind. So I will give examples for each of these. So let me first start with, whenever it comes to multiple choice questions, we need to first learn how to carefully craft this because these multiple choice questions will cover a range of outcomes. There are so many outcomes we can actually look into. The second one we need to look into is we can actually use a lot of statistical evidence to reveal areas of misconception and error. Okay, I'll be talking more about this in this session. And lastly, whenever you design a question, so what I would suggest is you should have a question bank. So whether it's a school or as an individual teacher, you need to have your own question bank. And then based on the statistical evidence, so once I conduct the test, based on the statistical evidence, I can also go back and change the distractors if I want. So that is what I call it as constantly monitoring my multiple choice questions every time, going back to my same questions and then changing the questions if required or changing the options if required. I will also talk about that in this session, and then analyze the effectiveness of these MCQs. Okay, so these are the three major things which we are going to focus today. So the first one, let's talk about the components of this multiple choice question. There are some key components here. The first one is like there's something called context. Okay, so normally what we look at is we normally look at a question with 4 choices, but it's not like that. Question is different, STEM is different, context is different. And then if you look at the 4 options, there is only one answer key. The remaining are called distractors. Actually, these are very important. The distractors as a teacher, so or as a question paper designer, my focus is to distract you. I should not allow you to choose this answer key, right? So that is how I am. I should be more concerned only about these 3, not the key actually. So how well I'm distracting you. So that is my main goal. So first one, let's talk about context. So what is this context? And then what is that STEM? What is this question? So context is something like, let me give you an example and then see in all my questions, I will have these parts. So this is the template for designing a multiple choice question. Now let's take a simple example. Now say my context is surface area of a cube. Okay, suppose if that is going to be my context. Then what I will do is I will give a small piece of information. So which will not have any question there. So that is called the STEM. So this information you can actually look at here. This is like consider a big cube of side length 3 centimeter made up of 1 centimeter cubes as shown. So you can see this is that cube here. So you have this small unit cube. This is actually a 1 centimeter cube. And you can see that this side length is 3 centimeter by 3 centimeter by 3 centimeter. Okay, so, but do you have any questions here? So there is no question, right? So this is actually called the STEM. So without the question. So it contains a small piece of information. Now what I will do is I will also share, you can actually see that, so this is the cube I'm going to have. Okay, I actually work with a lot of manipulators because I create questions using manipulators. I use a lot of softwares for creating questions. I'll be sharing few things with you. I use GeoGebra, I use Desmos, and then I use a lot of hands-on manipulators like this for creating, particularly for creating questions. Now you can actually look at a cube like this. So this is, I have a 1 centimeter cube, and then these are actually hex-length cubes. So I have made a big cube using 27 small pieces of cubes. Okay, so each cube will look like this. So each cube is like this. Now there is a pattern here. Now I'm going to create a question out of this. The question is going to be, now look at this. So if you remove 1 centimeter cube from each of the corners, okay, of this big cube. So what I actually mean is you can see there is a pattern in this cube. So you can see the corner cubes are green in color. So if I remove these cubes from these corners, what will be the surface area of the remaining cube? So you need to actually picture that remaining cube in your mind. And then don't worry about the answer now. Let's come back to this distractors and answers later. Okay, so this is the question. So you can see there's a difference between the STEM and the question. So the STEM carries just a small piece of information. So there is a big cube of side length 3 centimeter, which is made up of 1 centimeter cubes. And then, so that is the STEM. Now I have asked a question. Now what I can actually do is I can keep changing the question without changing the context of the STEM. So now what I will do is don't worry about the answers now. Okay, let's come back to these answers later. Now look at this one. I've changed the question. Okay, so now let's go back to this. Can you imagine that cube without these corner cubes? Is it possible for you to imagine how that remaining cube would look like? So if I remove all the green cubes here, yes, so it'll actually look like this. It'll actually look like this. Is it visible for all of you on the screen?
Yes, sir, it is visible.
Yeah. So, so if I remove the corner cubes, so all the 8 cubes from this corners, the remaining cube is going to look like this. So I'm asking you, so if you take the surface area of this cube, okay, and then remove these cubes from the corners, what is going to be the surface area of this one? So that's the first question. Now the second question is going to be, I'm not changing the context on the stem. So the context is still surface area of the cube. Now consider again the stem is like, consider a big cube of side length 3 centimeter made up of 1 centimeter cubes as shown. Now if you remove 1 centimeter cube from the center of each face of the cube, so what I'm going to do is, if I remove this one, so and then this particular one, this one, so like this for each face of the cube, if I'm going to remove 1 centimeter cube from the center of each face of the cube, and also remove the center cube of the big cube. Now, what will be the surface area of the remaining cube? So that cube is going to look something like, so this particular one. Can you see this? So from this cube here, what I'm actually doing is I'm removing all the cubes, the center cubes here from each face of the cube, and also I've removed the center one. So you can see a hole there. So if I do this, now what is the surface area of this particular cube? Okay, so I'm changing that question. I will keep changing questions alone without changing the context and the stem. So this is how you can actually design a multiple choice question. Now you can also now change the, change the pattern. So instead of like this, so now I've just colored it. You can see I can remove those colored cubes and then ask for what is the surface area of the remaining cube. Or what I can do is I can change the context now. Now I will keep the questions and the stem as it is. So I'll go back to my first question. And then what I will do is I'll change from surface area to volume. So if my context changes, now if it's going to be volume of a cube. Now again, you say that consider a big cube of side length 3 centimeter made up of 1 centimeter cubes. If you remove 1 centimeter cube from each of these corners of this big cube, what will be the volume of the remaining cube? So the first question was about surface area. Now it's about volume, right? So you can actually design questions something like this. And so these are actually called sibling items. So when you change if you have one particular context and then keep changing the questions alone, you call that as sibling items of this particular context. Now you can use this cube, you can change the color of the cubes. I mean, you can remove different set of pair of cubes, or you can change the number of cubes in your bigger cube. It could be 5 by 5 cube, it could be 3 by 3 cube, 2 by 2 cube. It's your choice. So you can play around with different shapes, asking for surface area, volume. So this is what we call it as sibling items. Okay. So any questions now with respect to sibling items? You can just post it there in the chat box if you have questions. Or I will give you one more example where, see, normally what we do is now we are moving towards integrating subjects. So you can also integrate math with other subjects, like you can integrate it with physics, you can integrate it with chemistry. You can ask a lot of questions. Let me give you another example just to understand sibling items alone. Okay, so we will come back to answers later. Just to understand sibling items, see, this is a very basic question. You can see blocks are stacked on a table and masses are given in terms of m, so the mass of the smallest mass. So now, if you look at the stacks here, A, B, C, D, and E, I've not asked any question. So what I am actually doing is, I have my context is stack blocks, and then I've given a piece of information. So what I can actually do is create questions, something like which stack has a greater mass. This is just for primary kids. Okay, so which has a greater mass. Or what I can actually do is what they will do is they'll just count and then tell which stack has a greater mass. Or I can ask them to rank the total mass of each stack from the highest to lowest. Okay, and then I can ask for which stack has a greater average mass. So what we do is we calculate mean here. So when you ask for an average, so we know in math, whenever we calculate average, so we'll take 5m plus m plus 3m divided by 3. So that's how we calculate average mass. And then I can change the question like rank the average mass. Or I can change it, say I'm not changing any context and stem. The context and stem remains the same. So what I'm doing is which stack experiences greater force exerted by the floor. Or I can change it to rank the force on the stack applied by the floor. Or again, I can change it to if these stack blocks are placed on a conveyor belt and if they move with a constant velocity of 3 meters per second, rank the magnitude of net force. Or rank the force exerted by the block placed at the bottom on the immediate block above it. So these are something called without changing the context of the stem. If you keep changing the questions, so this is actually the template for creating multiple choice questions. So this is just to understand what is called sibling items. So we name this as sibling items here. So now we will move on to something called designing distractors. This is the most important aspect when it comes to multiple choice question. So how do you design distractors? Actually, distractors are not randomly chosen. Okay, if you carefully observe the question, so I will give you a question here. So I've just taken a very simple question from the middle school mathematics. My context here is area of a triangle. Okay, and the stem is, you will simply say consider a triangle ABC as shown. And then the question is, what is the area of the given triangle in square centimeter? Okay, now I need your participation. You can actually start working on it. Now you know the answers, right? So the answer to this question is, I will just work out the answer. So the first one is, we know area of the triangle A is half base into height. So if I just calculate, this is going to be half, and then my base here is going to be 6 into height is 4, right? So your answer is going to be, so this is going to be 12 square centimeter. See, always try to have the units in the question itself. So that what will happen is you can just only enter the numbers in your options. So the key here is going to be 12. Right. Now, how do you design this distractors? So what I'm going to do is, I know where my students will make errors. So I will purposefully make those errors and then design those distractors. So the first thing what I will do is, see, students will take, this is going to be half, they know half BH, okay, half base into height, but they don't know which is the base. Some students will get confused with, should I consider that 3 centimeter plus 6 centimeter as base? So sometimes they will say, okay, instead of taking 6 centimeter, they will take this whole thing as base. So if they do that, then they will end up getting, this is half into 9 into 4. So if that is going to be an error, so the error is this one, right? So then your answer is going to be 18. So that is one of the distractors. So when a student makes that error, he is actually getting trapped because he is seeing that his answer is there in that one of the options there. Okay, so this is actually a trap. So he gets excited looking at that option without knowing that it's a wrong answer because he worked out something and then he's going to look at that answer in the distractor, one of the options there. He will try to choose this. Now, the second error which I will make is, suppose a student does not know how to choose the height. So maybe some students, they work out like this is 4, this is 3, and then they'll say this is a Pythagorean triplet. It's a right triangle here. So if that length is going to be 5, they will think, okay, I'm working out and then finding out that height less AB, that is an error. So then the next distractor would be half. Base is, if I have the base as 6 and then if I take the height to be 5, then this is going to give me 15. So that is another distractor. Or sometimes what will happen is some students might choose the base as 9 or the base as 6, and then they might take the longer side of the triangle to be the height of the triangle. I've seen all this with my students. So if they choose that, it's going to be half into 6 into 9.8. Okay, if they do all this, then you will end up getting these values. Okay, so 12, 15, 18, 29.4. But remember, these values are not randomly chosen. So you purposefully make that error, and then, yes? Any questions here? Okay. So you purposefully make those errors and then design those distractors here, right? So that is the actual trap which this is actually for me as a teacher or as a question paper designer. My job is to distract the students. So I should not allow them to choose my correct answer unless otherwise if the student is very clear with the concepts. So that is how we choose these distractors here. So they are not randomly chosen. See, I cannot choose if my answer key is 12. I cannot simply choose, okay, let me take 10 or let me take something like 14 or so something like 8, because these options will not make any sense. Even if they make an error, they won't end up getting 10, 14, and 18. Right. So you should not choose any random options like this. So always choose distractors, purposefully make some errors. We know what errors students will make. But is it possible every time to do this? Sitting and then designing, thinking about what error students will make, and then you have to make that error, design that distractor. It's going to take a lot of time. Okay, obviously, it will take a lot of time. Now let's take another example. Suppose the area of a circle is my context. Now you can see, consider a circle as shown. And what is the area of the given circle in square centimeters? So now what you're going to do is, you have to give me the key and 3 distractors. So they should not be randomly chosen. Yes. So I will just open my chat box. So area of a circle.
Participants also can unmute themselves and answer.
So may I speak?
Yes, ma'am.
So one could be using 2 pi r. We can calculate the area and give a distractor.
Yes,
Other
of
one,
course.
yes, the other one, instead of taking r as 3, they
Exactly.
can 6 and do it.
So your answer is first going to be A is equal to pi r square. Right? So let's first fix that key. So see, key need not be always the first option. We can change the options later. Yeah, so I'm getting 9 pi, 36 pi, 6 pi. Wonderful. These are the distractors, right? So now you know how to choose the distractors. They are not random numbers now. So how do you get that? So what is the actual answer here? It's pi. R is nothing but it has to be 3. So I've given the diameter here. So R has to be 3 centimeter. So therefore it's 3 squared. So 9 pi is your key actually.
Yes.
Okay. So now going for the distractors. So students might choose 6 centimeter as R, right? Without taking 3 centimeters. So if they do that, then they will end up getting its pi into 6 squared. So that will be 36 pi. So that will be one of the options. Okay, fine. So the next one is, how do you get 6 pi and 12 pi? So that is, if you use 2 pi r, they get confused with the formula pi r square and 2 pi r.
Yeah,
Most of the
even
times,
many times they in area they apply circumference, and in circumference they apply area.
Exactly. So if they do that, then purposefully we will do, okay, let's calculate 2 pi r. So 2 pi r, 2 pi into 3, And then I will also calculate 2 pi r as 2 pi into 6 itself instead of 3. So they might even make an error there, right? So if they do that, they end up getting this is 6 pi and this is 12 pi. So these are the options, right?
Also,
Excuse
3
me.
square, sometimes they may write 6, sir.
Yes. Yeah, that is also there. So see, the idea here is these distractors are not randomly chosen. Okay. So if your answer is 9 pi, it's not some random number like 10 pi, 15 pi. Yes, sir. Okay. Is that clear? Can we move on to
Yeah.
the next one?
Even one more thing.
Yes.
When we give pi in the answer, it becomes easier for them to solve. If we give value, they find it little difficult to calculate.
Exactly. See, when it comes to multiple choice, what we actually do is we need not check for what is going to be pi. We need not worry about the substitution part and then take pi to be 3.14. We need not worry about that. The answers could be in terms of pi itself. So let's make it easier for them. So this is one way of choosing. Okay. Now, let's go back to our question. Like, I want you to design the distractors for the cube answer. I mean, the cube problem here. Yeah. So now, can you give me the answer key and then 3 distractors? So this is the first question which we had, surface area of the cube. So now you know how to design a distractor. So you have to purposefully make an error and then give me the distractor. But instead of that, instead of purposefully making an error, what I will do is I will treat this as a classroom. So what normally I do is I will just give a question like this to my students and then wait for answers. Because instead of me breaking my head what error students will be coming out, what I do is directly enter the class, give that question, collect all the wrong answers, see whether the wrong answer makes sense. Okay, because even my wrong answer should make sense, like what we did before. So, and then if it makes sense, place it in the distractor. Yeah, so now coming back to this question. So this is the first question. So this is the cube, and then I've removed all the corner cubes here. So now what will be the surface area of the remaining cube? Yeah, answers.
Anyone who wishes to answer can unmute and answer. So we've just got
So you
an
are
answer
saying key is 30 square centimeter, 54. Okay, see, I'm getting options like one option, I'm just getting it as 30, 54. I'm getting a lot of 30s. This 50, 30 again, 54. Okay, 48. 27.
46.
46. I'm getting too many options now. Okay. Okay, fine. So let's see. I want, okay, see, anyhow, since I have too many options in front of me, I need to choose only 3 distractors and then 1 answer key, right? So what I will do is first let's look at this cube and then narrow down, finding out what is the answer for this. And then I want you to answer how did you arrive at these numbers. Okay, so the first one, So what is the surface area of this cube before removing the corner cubes? So now the question is, what is the surface area of this one? Yes, 27 could be a distractor. I do agree.
54.
Wonderful. 20, yeah, 54. So 54 is actually the surface area of this cube, right? So see, the surface area of the cube is like, you have, this is 3 times 3. So this surface is going to have 9 centimeters squared, right? And then you have 6 faces like this. So therefore, what you can do is, so the surface area is 6 times 6 faces into 9 centimeters squared. So which is going to give you 54 centimeters squared. So that is the surface area of this whole cube. Now, if I remove these things, then what happens is, you can actually look at this cube. So it's going to look like this. This cube is not losing any surface. Imagine something like this. Say I have this corner cube. Okay. So imagine this corner cube is here. So what happens if you remove this cube, this face, this surface is being created here. You can see this here. And this top surface is being created here. This side face is being created there. So it is not losing any surface. See these 3 sides, look at these 2 sides. If it goes out, so it creates those 2 surfaces here. So it's not losing any surface. So the surface area does not change. So the answer to this question is 54. Okay, so
Yeah.
this is
Actually, it will distract with the volume, because volume will change, but the surface area will remain same.
exactly. So my answer key is going to be 54, right? Now the first distractor, as you said, we can choose is 27 because they will get confused with the volume, right? But what will happen is, before taking 27, is there any other option? What normally they do is, they will remove all these cubes, because since you're removing these cubes, they will think for it's 27 minus 8. Can you understand? Because that would be little more. Okay, you can also have 27 if you want. You can have 27 as one option, or you can also have 19. Then, okay, how did you arrive at 30, 48, and 50? Because I need to understand what
Can I
error.
speak?
Yes.
Sir, 30, because I thought that because the corner cubes will be, taken away, so they might think that the faces left is made, each face is now made up of 5 cubes. So 5 into 6, 30. That's how I thought it will be. They'll
But
think
it should
that
be
way.
5 into 8.
No, sir, 6 faces.
Right. But you can see there are 8 cubes, right? At the corners.
No, sir. If the corner cubes are taken away, then
Oh, you
there
were
will
saying
be
this
left.
is 1, 2, 3, 4, 5, 6, 7. Even then. Okay. So you got something confused with 30. 48 and 50. So any guess? See, they
48 might be like 8 cubes are removed and 6 surfaces a cube has. So they might multiply it 6 are 48.
Okay. So the other option could be, say, if they imagine something like, okay, this particular corner cube is going to lose 3 surfaces, one on top, this one, and this one. So imagine if a student thinks like, okay, this is losing 3 surfaces because it's 1 centimeter into 1 centimeter. So into 3 sides. So 3 centimeter is going out. Imagine something like that into 8 cubes. So you need to subtract 54 minus 24. So that will give you 30. Okay, so that could be one option. And of course, as you said, there could be other options, but again, keep in mind that these distractors are not randomly chosen. Is that clear now? So can we move to the next question? Yeah, so this question is like, again, I will go back to this one. Now you need to find the surface area of this cube. So now give me the answer for this one and also the distractors. Okay, I think this is going to take a little bit time for you. But of course, see, the problem here is I'm not worried about the answer or the distractors. So the point is very clear, like you can arrive at an answer and then choose the distractors in such a way that students will make some error and then finally arrive at that particular answer there. 48 is a distractor. Okay. So it's 54 minus 6. Fine. 48 could be one distractor. I agree with that. So because you need to think about, if you look at this particular cube, see, you have to actually see that new surfaces are created inside. You have to count for that. Okay, it's not just removing these cubes here. You can see when you remove that particular cube there, you can actually see that new surfaces are being created. So is 60 a distractor or an answer key? It's 54 plus 12 minus 2. Is that the answer or 72 exactly? So see, it's actually what happens is.
Hello.
Yes.
Hello.
Yes, sir. Yes, sir. I could hear you.
Gopal sir, you can go ahead and say, we can hear you.
Hello.
Yes, sir. We can hear you.
Sir, it will be 54
Yeah.
and the minus 6
Yes.
and three more surfaces per 6 cube will be added. 6 into 3, 8, 18. That will be added.
4 surfaces for each cube. So when you see, when you just remove this particular cube,
then 6 for 54 minus
No.
6 faces.
54 minus 6.
That will be
It's
48.
actually 54 minus 6 plus 24.
Yes, plus 24. That will be the final answer.
72. Yes. So 72 is your answer key.
Yes.
Wonderful, sir. So I leave the distractors to you. Now you can make a lot of errors and then find the distractors. Okay, so 48 is a good choice because students will not think about the surfaces being created inside. They will just think about, okay, it's lost. This surface is lost. This surface is lost. So they will simply subtract and then see 48 as an answer. So wonderful distractor. So what I am more concerned about is the distractor, not the answer key. Okay, because everybody is worried only about the answer key. But as a teacher or as a designer for the question, we should be more concerned only about the distractors. That's the main part in this multiple choice questions. Or you can even rename it as, instead of MCQs, you can call it as multiple distractor questions. Because it's actually the multiple distractors. There's only one answer key. And there are multiple distractors. Okay. So let's go for the next one. I'll just go to, sorry, I'll just move this screen. Yeah. Now, once we have done this, okay, suppose you're going to test your questions with your students in class, you have to focus on the suspicious distractors. See, the first thing is we have already done what is something called sibling items. without changing the context and the stem. You keep changing the questions, or keep the question, change the context. You can do all this. Now, what is this suspicious distractors? Now, what we actually did is, I took this question, I tested this question with a lot of students. Actually, we took a sample of around, say, 1,000 students. Okay, and if you look at the answers, we could see that 38% of the students have chosen the first option, 12 centimeters squared. And 32% has chosen 18 centimeters squared. 7% choose 15 centimeters squared, and 23% have chosen 29.4. Now, I could see that the remaining distractors, these are actually very suspicious. In the sense, it clearly tells me that 62% of students, they have not understood the concept of calculating area of a triangle. So leave alone the formula. So if they couldn't, now this clearly tells me what I can actually narrow down is, by choosing these statistical data, like how many students have chosen each of these options, it tells me that 32% of students doesn't know how to calculate the base of the triangle, because I know 18 is nothing but it's, see, how do you get this 18 here? It's actually half into base you chose at 9 into height is 4. So if you do this, you end up getting 18. So if you end up getting 18, these many students, they don't know how to calculate the base of the triangle. So they are actually choosing this as the base. So now I can address specifically that, okay, these students need to understand that the base is something like BC is the base, not DC. And if you look at 15 centimeters squared, they don't know how to choose the height of the triangle, right? So this percentage of students, they have done this one. So they have calculated that AB to be 5, and then they have done this as half into base as 6 into height as 5. So that ends up getting 15. Now, these are called suspicious distractors. So we need to collect this information. This is very, very important. And it's actually very useful for giving a proper feedback. So when we do this, you can actually look at, this is what we actually call as suspicious distractors. And there is something called non-distractors. What are non-distractors? Actually, I have just mentioned here. You need to look for non-distractors. In the sense, suppose say, if I give some random number here instead of 29.4, something like that, if I give something like, say, 9 centimeters squared, where you will not, even if you make an error, if you're not going to end up getting 9. So imagine 0% of students have chosen that. Okay, then that particular option will be called as a non-distractor, because that option has not distracted any students. So in the next examination, what I will do is I will change that distractor. Because say when you have a non-distractor, now the chance of getting a right answer increases. Now, if you have 4 choices, then the probability of getting the right choice is now 25%, right? Even if randomly chosen. But if there is a non-distractor, and if a student is going to work out and then choose this, then what happens is you're increasing the probability of getting the right answer. So the non-distractors has to be removed. This is what I mentioned, that every time I need to analyze and then see whether my questions are, I need to just go back to all my questions once the test is over. So I need to give these questions to my students. When I get back these questions, I need to calculate the percentage. It's actually easy to calculate. Now we have softwares to do this, because most of the multiple choice questions are OMR based. When you feed in the sheet, OMR sheet, into the scanner, that software gives me this percentage. Or at random, what we can do is we can just enter the class. We can just count it. There are, say, around 30 students. We can easily count how many students have chosen each of these options, and then have a rough idea of what errors they have made. Okay, so this is one of the best way to get the feedback. Now, okay, so what we should do is once you get this, once you get the suspicious distractors, once you get that percentage, now you can do the remedial class. In remedial class, what you can do is instead of asking them to calculate the area, because I know that 32% of students could not understand, or even they could not calculate what is the altitude, or they don't know what is the height, or I mean base of the triangle. So I'll break down that question and then ask them to first find out which is the altitude of this triangle, or can you tell me which is the base of this triangle? So these are the remedial questions. So this is what we call it as hand-holding them and then teaching them. See, this is the objective which I told you at the beginning. Okay, are we going to handhold my students and then make them learn better? If I have to do that, if that is going to be my objective, then I need to break down this question into smaller concepts based on the suspicious distractors. Okay, now the next type in multiple choice questions is there's something called hinged type of questions. What do you mean by hinged type of questions is, see, you're going to test various items in one single question. Now look at this question. I think. So if you look at this particular question, the slope of the graph shown is. So if I ask you this question, what you're going to do is you will just calculate the slope and then choose the answer. Right? This is one single question, but I don't want to do this. Instead, what I will do is I will go for this type of question. I will give the slope in my question. So which of the following graphs has a gradient of 2? Then now what I will do is I'm actually finding that the student is going to work out slope for all the graphs here. So there is a difference between these two questions. Can you see this? So this is one single graph. You just work out only one slope and then choose the answer. But instead of that, if I give you 4 graphs and then ask you which of these graphs is going to have a gradient of 2, at least I need to work out 2 to 3 graphs in order to find this answer, right? So I'm actually giving a lot more. See, this is something like what we call as, this is kind of recall, or I'm making them work the slope formula again and again in one single question itself. So this is called the hinged type of question. Okay, you can work on this. So I'm not going to deal with a lot of math here. The next one is about, we will work on questions called where you can integrate math with the other subjects. Let me give you a simple example. In grade 10 or in grade 9, we introduce graphs, equations of straight lines, and also parallelly you teach optics in physics, right? So here what I have done is I've taken a graph. Okay, now the context here is equation of a reflected light ray. Now I know there is a light ray here. Now if I write an equation for that light ray, if I call that line the incident light ray is x plus y is equal to 1, instead of simply saying there is an incident light ray, so I'm going to give an equation for this line. So for this line, so you can see the graph there, and I'm placing a mirror on the x-axis. So this is my mirror. Okay, so now the question is, if the equation of the incident light ray is x plus y is 1, what is the equation of the reflected light ray? So now I'm actually trying to integrate optics with my coordinate geometry. Is this clear? And now you can again go for designing the key, distractors, all those things. It's very simple here, because you know that in physics, they would have learned that if you draw a normal, so you need to draw the normal somewhere here at the point of incidence. So that's your normal. So if this is angle of incidence, then angle of reflection will also be same. So that light ray should go like this, right? So you need to find the slope of that line and then change this equation. So all you need to do is, you know that if this line has an equation of x plus, sorry, if this is going to be x plus y is equal to 1, so you can write it in the equation form mx plus c. So you will write it like y is equal to minus x plus 1. So that's the equation of the incident light ray. So the reflected light ray is going to have a negative slope of this. That's all. So you will have, this is going to be y is equal to minus of minus x plus 1. That's the equation for the reflected light ray. It's as simple as that. Okay, so what will be minus of minus x plus 1? So you will say that, okay, so this will going to give you x minus 1. So you can see the y-intercept here will be minus 1, and this will have a positive slope of plus 1. So this is your reflected light ray. And they can make a lot of errors here. So it's easy for me to design the distractors for this particular question. But this is going to be the future. Like, people are trying to now integrate subjects. So in one single question, I can test the concept of optics. I can test the concept of straight lines. Okay. So any questions here? Can we go to the next one? Yeah, x minus y is equal to 1. Fine. Okay, so now I will go to another question. I'll give you another example. Now, if I just graphing the path of a ball, if I just throw a ball vertically upwards with an initial speed of 50 meters per second, now which of the following graphs depict the motion of the ball? Okay, so what I will do is, so quickly, let me go to, I will take a different, just give me a minute. I'll just stop sharing and then I'll open a different screen for a moment. Yes. Okay. Now I'm just sharing my whole screen here. You can see this. So I'm using GeoGebra here. Now, see, normally what happens when you throw a ball, it's a quadratic equation. But so let me just give you quickly. So we have quadratic equations like y is equal to x is a very simple straight line equation, right? When you want to change the slope, see, you can actually create questions once you start doing a lot of animations here. So how can you make an animation? If you want to change the slope of this line, you can just type y is equal to kx. And then it will ask for create sliders. So when it creates sliders, what will happen is you can actually move this value of k. K is nothing but slope. So you can actually basically see it varies from +5 to -5. And you can actually start doing animation on here. So it will change the slope on its own. You can also look at, you can go to object properties. Let me have this here. Yeah. So if you look at the object properties, you can change the interval between minimum and maximum values. So maybe I can just change this to -1 and then this to +1. If I just do it like this, -1 to +1, if that is going to be the maximum and minimum range of the slope. Okay, and then you can also change the speed. So this is how it will oscillate. So you can basically take a straight line, do everything with the straight line, and then create questions from there. So let me give you another example. So let me open a new window. So if I take y is equal to, okay, so now what I have done is I've taken a parabola, right? So imagine something like this. Whenever we teach math, we need to give them, see, nowadays math is no more abstract. With all these softwares, you can actually do a lot of animations. You can use GeoGebra for every part of math because you have the algebraic window on the left hand side, you have the graphical view here. So now what you can do is, when we teach say quadratics, we can tell them, okay, there is something called a parabolic graph, and imagine something like this. Most of you have seen a lot of movies, like animated movies. Let's take the movie called, say, Avatar. Okay, so there is a dragon bird which flies. So when you want to make a bird flap its wings, the first thing a programmer needs is the idea of a parabola. So what he has to do is, so when I change the slope, the value of k here, okay, you can actually see the wings of this parabola will go down and like this. So this is the first idea of flapping a wing, flapping the wings of a bird. Now you can basically go to the object properties and you can see, okay, the bird will flap its wings. Like I will make this 0.5 to maximum value of plus 0.5, and then the speed to say 10, and then say animation on. So this is what the animation will look like. So it's a simple parabola. What I'm basically doing is I'm changing the value of k, right? So there is an inverted parabola. And what is that equation? It's going to be y is equal to minus of x squared. Y is equal to x squared is one parabola. Y is equal to be minus of x squared is another parabola. So when you throw a ball, it's going to be y is equal to minus x squared parabola with a shift in the origin. So they need to understand all the concepts before going for, so before going to this graph. Okay, so the answer is going to be this particular graph. When you throw a ball, the graph is going to look like this, not a straight line, because you can see that whenever you throw a ball, the displacements are not linear. Okay, so this is something which every student needs to understand, that they have to be thorough with the concept. You can actually integrate a lot of concepts. You can integrate math concepts with science concepts. And basically, you know that math is the language of science. Okay, so just keep this in mind while designing the questions. I'll just stop here I'll just take 2 minutes. One of the main ideas, so what I would like to stress upon is this one. Distractor should be, it actually should represent errors commonly made by students. This is the main key point which we need to understand. And whatever correct answer you are choosing, it should be defensively better than other options. Okay, so it's actually choosing the best option. It's not just the right option, you're choosing the best option. And there are 3 key takeaways which I would like to leave it here. One is, try to create a template. As I showed you, you can create sibling items and then try to integrate subjects. So that is one key point. The second one is, please do collect suspicious distractors. This will really help you in giving a proper feedback to the students. The third one, it's easy to design MCQs using students, because you need not break your head in order to find that what errors my students will make. Just pick few questions, get into the classroom, give those questions to students. You will get a lot of wrong answers. All you need to do is choose the proper wrong answers. That's all. Okay, even the wrong answers should make some sense to us. So that is what we are going to do. And so by doing this, you can actually use your MCQs as a pre-assessment tool. You can use it for formative assessment, summative. You can also use it for remedial assessment. And as a teacher, what I would suggest is, every individual teacher should have your own question bank. Then imagine something like this. It's not easy to create a question bank overnight. Okay, just try to create 2 questions or just at least 1 MCQ questions every day. So if you do that, imagine in just 2 years, or if you just do 2 questions in a year, you will have around 700 questions with you, right? So all you need to do is slowly keep working on this multiple choice questions. Try to create your own question bank, keep it with you. So you can have it in your, as a school, you can have a question bank, or as a teacher, individual teacher, you can have a question bank. And not only that, also try to validate that question bank with some experts. Okay, so this is what I would like to suggest. And then now I'll just leave this floor for a few questions. And I'll call this as the MDQs, because this is what I would like to call it as. It's not multiple choice questions, it's multiple distractor questions. So I think I'll stop here. So
Sweetie ma'am, you can unmute and ask the question to sir.
Yes.
Good evening, sir.
Good evening.
Sir, for the parabolic question,
Yeah.
the ball throwing at a speed of 50 meters per second,
Hmm.
they will only identify the parabola, the downward parabola, up, moving down. But how it will be difficult for them to identify from B and D options?
Okay. Can I just share it? Yeah. Sure.
Yes, sir.
So you're saying that between these two.
Yes, how the child will able to identify, and
Okay.
because the question has only the speed given.
Yeah. See, when the speed is given here, okay, so when it is 50 meters per second, I'll quickly work out here. So I'll just show you something like, see, when you throw any object at some initial speed, so it will reach its maximum height. And say if this is 50, it will reach in 5 seconds. So the time taken to reach this maximum height is going to be 5 seconds. So if you throw it at say 30 meters per second, it will reach its maximum height in 3 seconds. What actually I'm doing is I'm dividing by acceleration due to gravity. I'm assuming it to be 10. So it's a quick way of doing it. And then what happens is at time t is equal to 1 second, it will travel a distance of say 45 meters. Sorry. At 2 seconds, it will travel a distance of 80 meters. At 3 seconds, it will travel a distance of 105 meters. At 4 seconds, it will travel a distance of 120 meters. And at the 5th second, it will travel a distance of 125 meters. Okay. So what I'm going to do is I'm going to plot this, and then it has to come down. So it will come back at, this will be at 6 seconds. It will come back to 105 meters at 7 seconds. This is at 8 seconds. This is at 9 seconds. This is at the 10th second. So you start with t is equal to 0 and end up t is equal to 10. So if you plot this, so you need to actually go back and then just give me a minute. Yeah, I'll just take this.
Sir, may I have one question, sir, please?
Yes, sir.
Can you please go to the question, sir?
1 minute, sir. I think I just. Which question you want?
Just previous question, the parabolic path. That ball thrown to 50 meters.
I got it. See, the question is, I'll just read out the question because I've just opened a new window here. You're throwing a ball vertically upwards with an initial speed of 50 meters per second.
Sir, here is my question is that if you're throwing a ball 50 meters per second vertically upwards, then I hope that it will not travel parabolic path. It will just move in a straight line. When it reaches to maximum height.
I'll just show you, sir. I'll just show you here. So what I'm going to do is, see at 0 seconds. So I will first change the axis, X and Y axis here. So let me put it like it's 1:20. Sorry.
Because we are not giving any angle, no, sir.
I'll show you, sir. I'll show you. I'll just show you. Okay. So see now. See, for the first one, I'm just going to enter something like at time 0, it will be at 0,0. Okay, so the second one is at time 1 second. So my x-axis will represent time. So in 1 second, it will travel a distance of 45 meters. So that is the second, that is at time t is equal to 1 second. At 2 seconds, it's going to be at, it's 2,80. So at 2 seconds, it's at 80 meters. So the height from the ground is going to be 80 meters, or you can take the displacement there. So at 3 seconds, it is, you can actually work out all this. At 3 seconds, it's going to be a 3,105. And then at the 4th second, it's going to be, it's 4,120. And then at the 5th second, it's going to be 5, 125. And then the 6th second, again, it's going to come back. It's 6, 120. And then the 7th second, it's 7, 105. 8th second, it's 8, 80. And then the 9th second, it's 9. I'm just plotting the coordinates of this point.
Actually,
9,
you're plotting the locus of the point of the distances it measures, right, sir?
Yes, sir.
Yeah, but actually, maybe they can confuse that. What is this? Which path they will move? The ball will move in the straight line.
It cannot be a straight line because the displacement is not linear, sir. So now what I will also do is I'll try to write an equation and then show you. See, look at this one. See, generally, when you write this, when you have a graph, something like this. So you have y and x, right? So when you have a straight line graph, something like this, or something like this, okay? So you know that this is your y-intercept. That's your y-intercept. And this is your y-axis, this is your x-axis. And when you try to draw a velocity time graph, okay, so you will get a similar type of graph here, but you don't get the negative values of x because you don't have negative values of time. But this is what you call it as the initial speed. And here the slope is going to be delta y by delta x. That will be your m. So here the slope is going to be change in velocity by change in time. So that will give you acceleration. Okay. So now when you write this is y is equal to mx plus c, you write it here along in y direction, you have v, your m is nothing but a, x is nothing but t, your y-intercept is u here. So this is a straight line kinematic equation. It's not just equations of motion. So when you actually go for higher grades, we call this as a straight line equation. It's a kinematic straight line equation.
Yes,
But when you look at the parabolic curve, so ax squared plus bx plus c is equal to 0. You call this as a quadratic equation, right? So your second equation of motion, what we call it as equation of motion in high school, when you go for higher classes, it's s is equal to ut plus half at squared. Rearrange it, it's half at squared plus ut minus s is equal to 0. This is a quadratic equation. It cannot be a straight line. So the equations governing a ball which is being thrown upwards is this one, not v is equal to u plus at. So therefore, it has to be a parabola. And not only that, when you just take this one, if you write the equation of that, okay, so s is equal to ut plus half at squared, which means y is equal to ut. So I can write u is 50 and t is nothing but my x-axis. So it's 50x minus half gt squared. G is 10. So what I will do is it's minus half 10 is 5. So it's 5x squared. That's the equation of this. So it perfectly fits into that parabola. Okay, so I've taken this picture here. So that is the picture which I gave you here in this question. So this option, you can actually look at the time limit. It's from 0 to 10, but this is only from 0 to 5. Even though it looks like a parabola, I'm very specific with the scale here.
Yes, sir. Yes, sir. Thank you, sir.
Yeah, thank you, ma'am. So any other question?
Hi, sir is still there. If anyone has any question, please raise your hand. Sir, Mr. Gopal, you can unmute and
Yes, yes, sir.
Sir, I want to.
Gopal's.
Yes, sir. Sir, you have taken in the equation y when the incident ray was there. The equation was y equal to x plus 1, I think. And after that, when you have taken the equation of the reflected ray, you directly change the whole of the right side, actually. So what logic you applied? Actually, the m will become -1. That is okay. But suppose directly if we do, then the children will get confused because
No. See, this is for our purpose. I'm doing it. I am not going to teach like that. So we know that the reflected ray is going to have a negative slope of this line.
Yes.
That's why I did that. Just to quickly, because all of us, we know, see, when I'm going to teach this in class, I need to do a lot of things. I need to show them what is the
y plus lambda equal to
exactly
perpendicular line.
That we can do it in class.
Okay.
Just for this purpose, I did it.
Thank you, sir.
Yes, sir. Yeah. Thank you. Any other questions? I think I'll just take one more question, or we can just wind up.
So what we can do is that I'll be sending the recording of the session with everyone. If anyone has any question, we can share with you and send the answer to them.
Sure.
Yeah.
Okay.
So thank you so much, Suryakumar sir, for the wonderful session. It was quite intriguing. And thank you everyone for being there and being such a great participant. I'll be sharing the recording with you, and we'll also look for the feedback from you on the session. Thank you so much, everyone. Have a great weekend. Have a great day.
Thank you.
Thank you, sir.
Yeah.
Thank you, sir. Thank you so much.
Thank you.